Okay, calculus, we have another piece here, derivatives. This is your introduction to derivatives. And really, the derivative that you've learned so far is in your last lesson, you found the slope of the tangent line. And that is, in fact, a derivative. The derivative is something that is based on another source. So the rate of change of the function, and we model that by the line. In mathematical terms of x and y, it means how y is changing with respect to x. And if you think about that idea of how y is changing with respect to x, that implies slope. So slope means derivative. Another thing is rate of change. That means derivative as well. Okay? So the derivative of a function f at a number a can be denoted by, so we said the limit as x goes to a of f of x minus f of a, all divided by x minus a. But the fact is there's another way to consider a derivative. And I'm going to draw out what definition 2 for a derivative looks like. Suppose we have a curve, and you want to be able to find the slope of a line tangent at a value of x, we'll say. That would make the y value f of x if this is your function f. Now, if we move over here, I'm going to move over h units to x plus h. That would mean that this output is f of x plus h. So the key piece I want you to understand is the distance between these two is h units. That's the tangent line. This is the secant line. We can see that the slope of the secant line is not the same as the tangent line. But the slope of the secant line would be y sub 2, or f of x plus h, minus y sub 1, or f of x. And we would divide that by x sub 2, which is x plus h, minus x sub 1, which is x. And what we would do is you can see that the x's cancel. So we get f of x plus h minus f of x all over h. If that looks familiar to you, it should, because it came from your pre-calculus class last year. And in order, that's the slope of the secant line. In order to do the tangent line, we draw that point closer. We draw x plus h closer to x. If x plus h gets closer to x, what's happening to h? And in fact, h is going towards 0. The way we draw h to 0 is we use that limit. So the formal definition for the derivative is actually the limit as h goes to 0 of f of x plus h minus f of x all over h. And if you want at a specific number a, you just put a in for x, and that will give it to you. So let's start with some basic ideas. The function f of x arrange the values in increasing order. Okay, this little prime value here, this thing means that. Okay, this means a derivative, f prime. So when you see f prime of negative 4, what it means is if this is the function f of x, how is the function increasing or decreasing at that spot? And if you look at a value of negative 4, 1, 2, 3, 4, okay, this is the spot at about where the function is at negative 4. How would you describe the function? I would say it would be going down really fast. In fact, I would say that the slope would be really negative. So f prime of negative 4, I'm going to say is really negative. Look at negative 3. The next one says f prime of negative 3. If you go over to negative 3 and you check the function at that spot and you look at the slope, I would say the slope at that spot is 0. Kind of has a flat line to it. Look at the function at negative 1. How is it behaving there? It's trending upward. I would say it has a slope of about 1. Look at f prime of 1. I look at 1, I see the function has a value there. It looks like it's trending downward. It's tangent line. That's its derivative. So we would say it's about negative 1. And then f prime of 3 over 1, 2, 3, looks like that's about my function value. I would say that that has a really positive slope. So when it says arrange the values in increasing order, we would say what's the smallest? Well, f prime of negative 4, that's really negative. Then the next one would be f prime of 1. That's just kind of negative. And then we would say f prime of negative 3. And then we would say f prime of negative 1. And finally, f prime of 3. And that is the order from least to greatest. You're just simply looking at the slope and describing it. Don't have to know it exactly in order to try to arrange them. Arrange these following in order of least to greatest. It would be a good idea for you to pause the video, try this one on your own, and see what you come up with. See as I go through it here. I have 0. That one looks like it's positive. F prime of negative 2 looks like it's negative. F prime of 0. That's less negative. So I'll put 2 negatives there because that's more negative. This is just less negative. F prime of 2, that's not quite as positive as the other. I'll put a 2 positive by that one. This one's just somewhat positive. And then F prime of 7, as I look at there, to me that looks like it's really negative. So least to greatest, I would say we'd have f prime of 7 is less than f prime of negative 2, which is less than f prime of 0, which is less than f prime of negative 5, which is less than f prime of 2, which is less than f prime of negative 4. And there you have it, okay? Order least to greatest. So when you're asked to find f prime, that means the derivative or the slope at a point. So again, that little tick mark up there, that means that we're looking at this guy, the slope of the tangent line. That's how we compute it. We're actually going to start computing that later on. Let's look at some differences between f of x values and f prime of x values. It says use the table provided below in order to find the following. It says find the average rate of change over the interval negative 2 to 4. Average rate of change means that we use 2 points. Instantaneous rate of change means we use 1 point. So average rate of change from negative 2 to 4, we simply use our slope. F of 4 minus f of negative 2 over 4 minus negative 2. So it looks like at 4 it has a height of 12. And at negative 2, it has a height of, well, I'm sorry, not 12, 6. Sorry. And at negative 2, it has a height of 20. So it looks like it goes from, 6, or from 20 down to 6. So it looks like overall the function's going down. As you look at these values, looks like it continues to go down. All of a sudden goes up a little bit here at the end. But overall, it looks like the average change is going down. Divide that by 6, and sure enough, you get negative 14 over 6, which is negative 7/3. So that's the average rate of change, negative 7/3. Over what two consecutive integer values is the average rate of change the greatest? Well, it looks like it drops 10 here, so the change is 10. Change is 8. Change is 6. Change is 4. Change is 2. Change is 16. So it looks like from 3 to 4, it goes from negative 10 all the way up to 6. So when is it the greatest? Greatest from x equals 3 to x equals 4. When is it the least? There was a spot here where it just changed 2. It dropped 2. Least from x equals 2 to x equals 3. Let's look at a different question. These are asking about average rate of change. Notice how I'm looking at f of x and I'm using slope and looking at the change to determine that. What says, what is the instantaneous rate of change of the function at x equals 1? Instantaneous rate of change, just to be clear, we're all understanding this together. If you have a function and you look at 2 points, that's the secant line, and that's the average rate of change. But if you look at a function and you look at the slope of the tangent line, that's instantaneous. That means f prime. So this tells us instantaneous rate of change. The question is, what's the instantaneous rate of change of the function at x equals 1? That'll be negative 5. What is the derivative of the function at x equals 3? Derivative and instantaneous rate of change mean the same thing. What's the instantaneous rate of change, or the derivative at x equals 3? Be negative 3. What is the equation for the line tangent to the function at x equals negative 2? Oh boy. Well, in order to find an equation for a line tangent, I need slope and I need a point on the line. Well, it says that an x value of negative 2. So I need the y value. So as I look at negative 2, which one's the y value? Is it 20 or is it negative 12? The answer is 20. F of x tells us the location. F prime of x tells us the slope. So therefore, we have y minus 20 is equal to negative 12 times x plus 2. Or y minus 20 is equal to negative 12x minus 24. Add the 20, y is equal to negative 12x minus 4. That's the equation for the line tangent. What is the equation for the line tangent to the function at x equals 0? Same thing. We need slope and we need a point. Your point is going to be 0, 2, and your slope is going to be negative 7. Notice that 0, 2 is the y-intercept. So we could just write y is equal to negative 7x plus 2. And we will skip question F. Sketch a graph of a function that satisfies the following. F of 0 is equal to 4. What does that mean? That means that the function goes through the point 0, 4. F prime of 0 equals 1. That means at this spot, the slope is equal to 1. F of 1 is equal to 0. That means it goes through the point 1, 0. And f prime of 2 is equal to negative 3. That means at x equals 2, the slope is negative 3. So I'm just going to draw a general graph here that tries to satisfy us 1, 2, 3, 4. We're going to go over 1 and 2. So what I want is as it passes through 4, it has a slope of 1. Okay? So I'm going to, have it about like that. So at 0, 4 has a slope of about 1. Then it says that it passes through 1, 0. So I have to come down and pass through 1, 0. And then it says at x equals 2, it has a slope of negative 3. So I'll draw it like that. You can see at 2, you can see that the slope looks like it's about negative 3. There's an infinite number of graphs that you could draw that represent this situation. I'll try to draw another one for you. Okay? 1, 2, 3, 4, and then 1, 2. So again, it passes through here, and it has to pass through here. Okay? And so you can go like this. You can drop down and then come back up and then have kind of a slope of negative 3 right there, okay? So say your slope is negative 3 right there. But here it passes through 0, 1, it passes through 1, 0, and has a slope of negative 3. The idea is that you're able to distinguish between point values and derivative values. Look at your next one. F of negative 2 is equal to 4. That means it passes through the point negative 2, 4. F prime of negative 2 equals negative 2. That means that the slope at that spot is negative 2. This means I pass through the point 1, negative 2. This means that the slope at 1 is 1/2. So I want to draw a graph that passes through negative 2, 4. And I want to have a slope of negative 2. Maybe something like that. And then at 1, negative 2, I'm going to have a slope of 1/2. So I'll go over 1, and I'll go down 2. At that spot, I want to have a slope of 1/2. So I think that would be reasonable assessment. Okay. All right, last examples. These are ways in which we interpret the meaning of derivatives. It says the temperature of a pot of water is modeled by the function C equals F of M. What that means is that the temperature in Celsius is a function of minutes or time. So as minutes go by, the temperature of the pot of water changes. Okay? Explain in simple terms what F prime of M means. Every time you see a derivative, you need to talk about a rate of change. This means the rate at which the temperature is changing at m minutes. So we're going to look back at what I wrote after we look at a real example. It says explain in short terms, simple terms, what f prime of 5 equals 10 means. That means at 5 minutes, the temperature of the pot is changing at a rate of, what is the rate? The rate is 10. 10 what? You have to put a label. 10 degrees per minute. Okay? So you're making some macaroni and cheese. And at 5 minutes, suppose that the temperature of the pot was 170 degrees. It means that we expect it to go up at about 10 degrees per minute. So in the next minute, it would be, say, at 180 you would expect. Okay? It does not mean that at 5 minutes, the temperature has risen 10 degrees. It's maybe 170 right now. Maybe it started at 60 degrees. So you don't, so this would be a change of 110 degrees. You don't know how much it's changed. You just know at time 5 that the temperature is going up at a rate of 10 degrees per minute. Some people say that after 5 minutes. No, it's not after 5 minutes. It's instantaneous. It's at time 5. That's what's happening. Look at the next one. The distance of runners travels modeled by the function d. So d is distance in miles. Okay. And h is time in hours. So as hours go by, the number of miles the runner runs changes. So explain in simple terms what f prime of h means. The rate at which the distance is changing at h hours. So explain what this means. It's very simple. At 3 hours, the distance is changing at a rate of 5 miles per hour, or the runner is running at a speed of 5 miles per hour. That's what f prime of 3 equals 5 means. It means that at 3 hours, he's running at a speed of 5 miles an hour. Some people write this incorrectly. They say after 3 hours, the runner has run 5 miles. No, my guess is that the runner's run more than 5 miles. Okay, he's probably run a ton of miles. I mean, three hours. That's close to a marathon for a lot of people. Okay, so maybe run 26. We just know at that time running 5 miles per hour. Okay, at 3 hours. The mass of a radioactive isotope is modeled by G equals, so this is the mass. Mass equals a function of days. So as days go by, my guess is that the radioactive material drops. So the mass probably drops. So F prime of D, that means the rate at which the mass is changing at D days. So this means at 2 days, not after 2 days, but at 2 days. Or on day 2. The mass is changing at a rate of negative 0.34 what? Its mass is measured in grams per day. This is what the derivative means. This is an introduction to derivative. I think probably the best example is the first example 7, should have been 6. But the idea that, you know, I'm sorry, this one up here, which should have been 6. The idea that f prime of 3 equals 5 means that a runner is running at a speed of 5 miles an hour. I'll give you one last example here. I travel each day from Albert Lee back to Owatonna. And the fact is that it takes me time. It takes me about 30 minutes. So if somebody asks me what is f prime of 15 minutes, okay, what that means is what is my speed when I've been traveling at 15 minutes? And so if you think about me going from Albert Lee to Owatonna, what would you think my speed would be at 15 minutes? Well, probably about 70 miles an hour. What if I asked f prime of 10? You'd say, well, it'd probably be 70 miles an hour because I'm sitting on the freeway. Well, what about f prime of 1? Well, at that point, I'm probably driving by high V in Albert Lee on my way out. You would say maybe like, say, 30 miles per hour. You say, well, what's f prime of 29? Well, that's where I'm coming into Owatonna, and I'm, maybe driving by the bank, and I'm going at, say, 40 miles per hour. So it's telling you what your rate of change or what your speed is at a specific time. That is what a derivative does. Instantaneous rate of change at a specific time. So very conceptual today. It's not going to be as conceptual as we move along. In your next lesson, we talk a lot about using, the definition of the slope again, using definition 2. So we'll get back to some algebra intensive things, and then we're going to get to some graphical representations as well, and a lot of algebra along the way. So today is very conceptual in terms of what does a derivative actually mean. So good luck. Please reach out if you have any questions, and I hope you have a great weekend.